Hello, I'm Jim Mollenauer, and I want to talk on this occasion a bit about Ethernet and its early history. This is the kind of folklore that has been likely never captured in the textbooks and certainly not likely to stay there very long. But I had the good fortune to be involved a little bit in the early history. Not that I invented Ethernet or anything, but I was present when a lot of things were done. This dates back, in fact, to the 70s, about the mid to late 70s. And at that time, most communication was done over modified telephone lines, and it was slow. But at the Xerox Research Lab in Palo Alto, they came up with a different idea. Now, the Xerox Lab at that time was really probably the most creative and inventive place in all of high tech, certainly in all of the computer industry. And I had the good fortune to go around with Alan Kay, whose design for computer interfaces really wound up a couple of years later at Apple and greatly influenced the design of the Macintosh. But in taking me around, he showed me a little cable that connected up all the computers there, which turned out to be called Ethernet. It's really a misnomer because the ether is just a name that physicists have used for a long time to indicate outer space, empty space. And in fact, Ethernet ran over a wire, though it can also run over a fiber. It isn't a wireless technology at all. But nevertheless, it's become very popular, and possibly the name has helped. What happened then was that Xerox decided that it wanted to bring Ethernet out of the lab and make it publicly available. They got together with Intel, the chip maker, and Digital Equipment, a computer maker, and the three companies issued an unofficial spec called the Ethernet Blue Book. This was roughly 1979. About that time, they felt it was a good idea to do an official standard, so they approached the IEEE, which is really a professional organization of electrical engineers, but nevertheless does a number of standards. Other things they do include standards for electrical power plants. At any rate, IEEE 802, this project was chartered roughly 1980, and the expectation at that time was that, well, they would do a standard for Ethernet and then go home. Well, that was over 30 years ago. They still haven't gone home. They just do faster and faster versions of Ethernet. But in its early stages, Ethernet looked a good deal different from the version you see today. Everybody ran on a common cable. That was the innovation. This cable ran all around the lab, and each computer hooked up to it. And this worked well because computer traffic is bursty. You want to send a file at one point, send another file later on. A bit of back and forth traffic, but it's not continuous in the same sense that video is or voice is. So it makes sense to have a high-speed transmission medium that's shared on a as-needed basis between a lot of different computers. And this worked very well, but to make that happen, they had to do some pretty tricky things. For one thing, the basic premise of Ethernet is that you have to listen while you're transmitting, not just before you transmit to make sure that the wire is clear, but even as you transmit, so that if there is a collision, then both parties can stop. And you can get a collision because two different computers at opposite ends of the wire may start transmitting at roughly the same time before the other party has noticed that the other one has started. You get that same effect, in fact, in voice calls. If you have delays due to packetization and due to a satellite link or anything like that, it's not uncommon for two people to start talking at once. And so computers do what people do, more or less. They stop. They back off a bit, and then they restart. And this is what Ethernet did. But it had a very precise way of backing off. Namely, if you have a collision, you stop, you back off a random time, then you try again. If you have another collision, you back off a random time multiplied by 2. You try again. fail again, multiply by 4, and so on. And it's shown mathematically that this recipe does prevent total jam-up, even if there are lots and lots of computers all trying to transmit. The fact that those who do experience collisions have to wait makes the thing stable, although sometimes it gets unfair in the sense that a latecomer who only has to back off a little gets in ahead of somebody who started earlier. But in fact, the success of Ethernet is quite partly due to the fact that most systems weren't heavily loaded at all. It didn't matter that even though they were rated at 10 megabits instantaneous transmission rate per second, they ran well below that and the system behaved fine. One other thing about it was that in order to detect another party transmitting while you're transmitting, the system is very, very subject to any kind of noise. So they went out and ran some tests, the engineers from Digital, and they went to the Burlington Mall shopping center, not too far from here, and they put up their RF level meters, and the needle went right off scale. There's a huge amount of RF interference from a nearby Air Force base with its radars, from high-tech companies developing radio frequency products, and so on. So Ethernet, as originally spec'd out, had 4 different braids of shielding to protect against any kind of ingress noise, 1, 2, 3, 4, and it made the cable quite expensive, especially if it's coated with Teflon, as this one is. So that was one negative about it. The cable was quite expensive, but at least you could go from computer to computer to computer and thereby not use a whole lot. But to connect up the computer to the cable was another very tricky thing, because the way one connected up the cable to the computer was to come up with a unit called a vampire tap, where the little clamp would actually hold the cable while it was being pierced by a little needle right in the middle, which would pierce those 4 braids of shielding and contact the center conductor without breaking it. Pretty tricky, but that's what you had to do. And so that was actually quite popular simply because it was much faster than using a modified telephone arrangement. But it was subject to maintenance problems. If something went bad, then you didn't know where along the cable the problem might be. This is true even though there were precautions in the electronics to minimize the probability of troubles, to put only 1 transistor in the actual path of the bits, and so on. But on a couple of occasions I can recall the technician coming into my office looking for a problem, putting up a big ladder, poking around inside the ceiling, dropping crumbs of asbestos in my coffee cup and stepping on my desk. Nobody was happy with this. So eventually a new version of Ethernet based on a hub with radiating cheap cable came into being. And that's the version that you see today, that there's a central hub and everything fans out from that hub on cable which is longer than a single cable connecting up everybody, but it's cheap cable, not expensive cable, and it works fine. And in fact, that hub at one time propagated the signal from any one of the legs of cable coming out of it to all the others, so that you still had the probability of collisions. But that has gradually been replaced with the switch arrangement, which enables multiple transmitters and multiple senders, as long as they're separate pairs, and prevents any kind of collision. There's just no issue of collision anymore. And what's really left of Ethernet is not the whole technology, the part that was patented, but simply the address format and the bit pattern used by Ethernet. Everything else that was really tricky and didn't always work too well, that's all gone. Now we have inexpensive hubs, we have Ethernet all over, connecting up other inexpensive devices. In 30 years it's evolved quite a lot. But meanwhile, back around the early 80s, when Ethernet was taken into the standards arena as IEEE 802, a couple more proposals came in that actually said, wait, we have a better idea. IBM came in called the token passing ring. There was another version called the token passing bus, which was constructed out of TV components, cable TV components. But the idea in the token system is you can transmit if you receive the token, otherwise you can't. It's an old idea. It goes back probably 10,000 years to tribal councils where somebody sits there with the talking stick, and as long as you hold the talking stick in your hand, you may speak. When you're done, you pass it to the next person. But otherwise, you don't speak, and this keeps order in the council, and it's a very, very old technology. And the IBM token ring worked much that same way. And indeed, under conditions of heavy load, it was really more efficient. But it required twice as much cable, the connector was messy, and in addition, there was an issue of a patent claimant who said that, if you use token ring, you have to pay patent royalties. Now, in fact, this was eventually broken in court, but for a period of perhaps 10 years, it really was there overhanging everything in the token ring arena. And as a result, Ethernet really got the lead in the marketplace, especially after the hub arrangement came in. And the token ring has just faded away. The token passing bus had the advantage of a much longer range, but it really only took hold in some large government bases, Air Force bases, Army bases, where there were miles and miles to cover, and it could do that where the other local area networks couldn't. But meanwhile, wide area networks are also being developed, and we have the protocol set normally called TCP/IP, or just plain IP. And both that and Ethernet were invented in the absence of any consideration of the other. Each was intended to do the whole job, at least for Ethernet within the building. And it took a few years to meld these together in an efficient way so that they didn't really get in each other's hair. But over time now, Ethernet has become very fully entrenched. The cost for the chips is almost nothing, and so you find it all over the place, showing once again that the cost of any technology comes down significantly with time, using the very versatile and remarkably applicable formula called the 30% learning curve. Namely, if the total volume of a technology doubles in production from the beginning, the cost comes down about 30%. So it will come down 30% with the first doubling, 30% of that with the second doubling, which adds up to about 50%. So every time essentially the integrated production from the beginning goes up a factor of 4, then the price comes down by half. And that has shown up in many, many technologies, including this one. But Ethernet has really been, despite the fact that its name is not quite accurate, a remarkable success story, and